Hello to everyone. My name is Raul Matos, and this is my show and tell for Module 8 of Discrete Mathematics about functions and cryptography. During the presentation, I will explain what is a function and the different ways that we can represent it. I will also explain some traditional applications of functions. From here, I will pass to the application of functions in the field of communication, especially in the area of cryptography, and explain why cryptography is needed. In this topic, I will explain what are the fundamental concepts of cryptography and how we can find functions in it. Finally, I will explain how we can implement that type of cipher, the Hill cipher, using some functions and coding. To begin with functions, here's a simple definition of a function. A mathematical function is a rule that gives value of a dependent variable that correspond to specified values of one or more independent variables. We can represent functions in different ways. We can represent functions as a table, or using equations, or using a graph. Uh, this is very important because we very often in real life we don't have the function defined. So we use the output that we have from measurements or ordered data to define a function to model a real life situation. Because we continually make theories about dependencies between quantities in nature and society, functions are essential tools in constructing mathematical models. As an engineer, we normally see continuous functions such as the distance, the velocity, or acceleration of a car or of a vehicle. We can also see the dynamics of forces or power of a mechanism, but we also see some finance, a continuous function of cost, investment, and mortgage. However, discrete mathematics is often concerned with functions that map between other kinds of sets, such as binary strings or a set of tasks. That's why I'm going to show one application of this type of sets, of functions in this type of sets, that is cryptography. First, the question is what is cryptography and what is important? Cryptography can be defined as the sign of secret of hidden writing. Cryptography is required because of a well-established need for secure communications. Some examples I can give is communications during wartime, uh, business transactions, or just the need to send a message to a secret love. So secure communication has some requirements. Here are the three main requirements. First is privacy. This means that only the intended receivers understand the message. Second, authentication. That means that the sender and the receiver need to confirm each other identity. And finally, the message integrity. This means that we need to ensure that the communication has not been altered or either maliciously or by accident or by the algorithm during the transmission. So for the first part of secure communication, we have encryption. Cipher is a method for encrypting messages. Here we have like a diagram of how we pass from a plain text, use an encryption algorithms, and produce a ciphertext. In the same way, we can go the other way and use a decryption algorithm to produce again the plain text. Encryption algorithms are standardized and published, therefore are reviewed and compared to other algorithms. The key, which is the input to the algorithm is secret. The key can be a string of number of or characters. If the same key is used for encryption and decryption, the algorithm is called symmetric. And if different keys are used for encryption and decryption, the algorithm is called asymmetric. One type of encryption or cipher is the substitution cipher. In this type of cipher, we use a key for the algorithm and then shift the alphabet. For instance, if the key is we use the string word, we will shift all the letters by 4 and remove the letters W, O, R, and D from the encryptions. So here we can show uh, some example where we remove the 4 letters and then we shift all the alphabet. And here is the interesting part. We have to ensure that the mapping is one-to-one. So we can define the function to use in the algorithm. So no single letter in a plain text can map to different letters in the ciphertext, and no single letter in the ciphertext can map to different letters in plain text. The Hill cipher is a polygraphic substitution cipher based on linear algebra. Each letter is represented by a number modulo 26. Often, a simple scheme is shown where we assign each letter a number, but this is not essential of a feature of the cipher. To encrypt a message, each block of n letters is multiplied by an invertible matrix against modulus 26. So to decrypt the message, each block is multiplied by the inverse of the matrix using the encryption. The matrix used for the encryption is cipher keys to be chosen randomly for the set of invertible matrix module 26. So this is a very important part to apply this type of cipher. So finally, using these defined functions and some coding, we can create a program that decrypts and decrypts a message using a matrix as a key. So here I present some part of a code that I implemented. So the input is going to be the message. In this case, we use a typical message that we use in this type of problems, a talk done. And we have a key, in this case, is an invertible matrix, 7, 8, 11, and 11. And we use these functions and algorithms to make operations on the message to create a ciphertext. So here we can see the output, and in the same way we can use these operations to decrypt the message and get back again our original message. There is a lot of fascinating topics about the use of cryptography. I hope this brief presentation gave you an idea about cryptography and how we can use functions and coding to implement these algorithms. So thank you again, and I hope you have a nice spring break.